Okay, we're going to learn the derivatives of inverse trig functions. They're all going to be similar. You will have to memorize these, but I'm going to give you a hint that typically only inverse sine and inverse tangent will show up on the AP exam, okay? It's not 100% guarantee, but it's like 98%, okay? So the chain will still apply, so you can be any quantity. So inverse sine, which remember all of these, if you have arc sine, just as a review because it's been a while, can also be written as sine to the -1. Okay, so these are going to be interchangeable. You'll see them both ways. Because it is inverse trig, there are restricted domains. There's a lot going on mathematically, so I've included a link down here in the proof. On your worksheet, you'll see a link. There's a YouTube video, it's about 5 minutes, and it kind of goes through all the history of inverse sine, the domain restriction, and it shows you a proof of the formulas that I'm going to just tell you, okay? So it's pretty interesting. If you like that sort of thing, I would definitely watch that video. And then all the other trig functions can be derived similarly. But for simplicity's sake, I'm just going to give you the formula to memorize. So arc sine is going to be 1 over the square root, and then it's 1 minus u squared. And then you always have to multiply everything by du, which typically ends up in the numerator. But I write it separately so you know that you actually need to do that. Inverse tangent is similar, but... Okay, so those are the two that are the most commonly seen, and it would be one multiple choice question. Now, arc cosine is similar. It's the negative of the arc sine. So it would be easy to memorize. Arc cotangent, same idea. It's the negative of tangent. Okay, and then arc secant, I don't have a good way to memorize this, but it's 1 over u, and then it's u squared minus 1, and then everything's times du. So that's the absolute value of u. Sorry, it looks a little messy. And then cosecant is the negative of arc secant. So the relationships have to do with the proof. Sorry, I'm trying to focus so I don't write the wrong thing. But there really is, like, y secant and cosecant are similar because remember those are the reciprocals of arc sine and arc cosine. So not the same formulas, but there are patterns. For our sake, we're going to practice 4 of them. And these are pretty straightforward. This should be a quick video. This is u. So we just have to memorize, oh, it's arc sine, so I know, I'll put it up here. We're looking for that. So our derivative is going to be 1 over 1 minus, and then we want to square that. So it's 4x squared. Square the 2 and square the x. The derivative of 2x is 2. So I'm going to, instead of just putting it next to it, I'll even put it on the top because that would be multiplied, so it would go in the numerator. And that's it. Okay. You typically won't be able to factor this or do any simplifying. All right, let's look at number 2. Arc tangent. So you're like, oh, that's the one without the radical. So this is u. So it's 1 over 1 plus square u, and then times the derivative of u, which is 3. So that 3 is going to go on top. That's it. Number 3, arc cosine was the negative of arc sine. So we're going to rewrite this as x to the 1/2. That's u. So we'll write this in 2 steps. It's going to be negative. We've got the square root, 1 minus. When I square the square root, they cancel. So remember, you just get x on the inside. The derivative is going to be a power rule. So 1/2 x to the -1/2. So to simplify this, well, we're going to draw a big fraction, the negative 1, and then I'd have a 2 and an x. So we'd have 2, we'd have root x, and then root 1 minus x. So they might actually combine these. Remember, with square roots, they will multiply together. So you could see your answer like this, x minus x squared. You just have to be flexible. And then there would be a domain restriction. They typically state that, but I'm not going to make you. And then the last one is arcsecant. So this is u. So you get 1 over the absolute value of e to the 2x. And technically e to the 2x won't ever be a negative value, so the bars might be gone on a multiple choice question. But for right now. Now here I'm going to write this. So e to the 2x, and that's squared minus 1, times the derivative e to the e to the 2x. So it's e to the u times the derivative of its exponent. Now in this problem, we can do some simplifying. Since e to the 2x, no matter what number you plug in for x, you're not going to get a negative value. Remember I said those bars could actually go away. And then because these are being multiplied, we can reduce. A power to a power you multiply. So this becomes 2 over e to the 4x minus 1. That's an x. And that's our derivative. So, all right, I'm going to let you try some problems on your homework. Let me know if you have any questions. All right, good luck.